Hey everybody, it's Mr. A here. I'm going to show you how to get your data from the Rotocopter lab into Google Sheets so that you can make a graph and complete your labs. I've called up Seth's lab report here, just picked a student at random, thanks Seth, and I've opened another tab with a Google Sheets doc, and I've already named it Rotocopter Sample Graph just for instruction purposes here. So we're going to take Seth's data and we're going to copy it into Sheets. I just want the numbers now. I'm going to leave his averages because I'm going to calculate my own. Some of these, anyways, let's just move on here. Command C is what I'm going to use to move the numbers over, and then I'm going to go to Sheets and I'm going to put them right in there. If you want to, you can make your headings first. So my headings in this case would be Rotocopter type, or in Seth's case, it was number of paper clips. Okay, so Seth had 1, 2, 3, and 4 paper clips. You might have wing length here, so you could choose small, medium, large, and extra large, or you could do paper size, or if you measured the wing length, whatever variable that you chose, whatever manipulated variable that you chose, you're going to put them in here, in these boxes here, okay, on column A. And then give it a title. So number of paper clips would be the variable that that Seth's group chose, Seth and Jacob. All right, across the top, you're going to have your trials. So trial 1, and the drop time was measured in seconds. Trial 2, drop time was measured in seconds. And trial 3, drop time was measured in seconds. And then we want an average. And in a lab, averages of 3 trials, they eliminate little errors. You can see outliers in your data, so you can get rid of that. And they just make your data a little more reliable, a little more consistent. I'm going to move my numbers up. For some reason, they're a little bit low. So we're going to pop them up into there using Command X to cut them and Command V to paste them where I want them. Okay, there's some strange things going on here, so I'm going to delete that high, and it looks like an extra 1 was added here, and it changed into a date. So I'm just going to make that a 1. Look over your data to make sure it makes sense, and there's no odd stuff going on. And then we're going to create an average. In Sheets, averages are really easy to make, and any kind of calculation is easy to make. The computer can do it all for you. So you hit the equal sign, and then it's actually suggesting something for me here, average B2 to D2, and that is what I want to do. But I'm going to type it in just to show you how to do it. So you want the average, and then create a bracket, highlight the cells that you want, and then close the bracket. Okay, hit enter, and it calculates the average for you. You don't have to type that all the way down. You can just highlight the cell and then drag that crosshair down once you hover over the corner, and the computer is going to guess what you want. It's going to copy that formula all the way down, creating averages of your 3 trials. Okay, and average is just adding up the first, second, third trial and dividing by 3, so you get some nice, good-looking numbers. And actually, these numbers kind of look interesting because it does slowly go down, except for that one, 1.12. All right, so there is a trend there, but we'll see later when we make our graph. Okay, to make a graph, you highlight all the data that you want to include, and you hit this little chart icon here. It might be hidden under Insert, and then Chart, just right there. It's going to take a guess at what kind of chart you want, and then you can go in and customize how you want that chart to look. Okay, very rarely can you just work with this chart. It's probably not finished. We need to add a lot of headings and make this thing make sense. So column chart is good, but we can just go over and see what other types of charts look like. There's a combo chart. There's different types of column charts. For this case, a column chart is a good idea, but what it did is it put number of paper clips as one of the series. So we want to get rid of that. Number of paper clips should just be on your x-axis. Okay, number of paper clips. Let's see if we can drag it. No, we can't. So we're going to remove it from the series. And the only thing I want in the series is trial 1, trial 2, 3, and then average. Okay, your x-axis, it doesn't have anything right now, but your x-axis should be your number of paper clips. Your x-axis always has your independent or manipulated variable, the thing that you changed in your lab. So here we're going to go select an x-axis. What data do you want? And we want this data. Highlight it, hit OK, and then it adds 1, 2, and 3, and 4 number of paper clips as your x-axis label. It's got a legend here, and the legend looks good, but we're missing some titles. We don't know what these colored bars represent yet. So sometimes you can get lucky and use row 1 as headers. Okay, that didn't really change anything. We're going to go into customize. We're going to add a chart title. So the vertical axis title, vertical is this one here. Vertical is your y-axis, and your y-axis in this case is drop time. Okay, that's what you measured. That's your responding or your outcome variable. And it was measured in seconds. So bracket S and enter. It looks good. It appears over here. You can change the font and the color if you want. I'm going to leave that for now. Your horizontal axis is number of paper clips. For you, it might be paper size, it might be wing length, or whatever variable that you chose to manipulate. Okay, if there's a unit there, then you want to add that in brackets. And enter. We also want to add a title. Chart title is a description of what your data is showing. So you don't want to just have Rotocopter Lab or Science Report, but you want to have a title that really describes what you did. So for this case, it would be drop time for different rotocopter models. Okay, something like that, a detailed description of what you did. You could mention the x and the y-axis in your title, but just don't do things like Jacob's lab report or some artistic title that you might use in English class. In science labs, you want to have a descriptive sentence of what your data is, so that anyone looking at your graph should be able to understand what you did, even if they weren't there in the class. Okay, series looks good. You could add a trend line. A trend line is going to take all the averages of all your data and give you, well, a trend line. It's going to show you the trend in the drop time as the number of paper clips increased. So you can see a nice slope there, and that will help you prove your hypothesis later. You can actually see that as you increase the number of paper clips, the drop time did decrease. Okay, and this is called getting quantitative about your lab report. It's actually showing with numbers how your hypothesis was correct, or in some cases incorrect. All right, you can change the color. You can add data labels, although it makes it a little confusing. You can add error bars. It's not appropriate in this case, but those are other things you can do. Your legend, you could move it around in different positions. This one looks fine to me. You could change how your axis labels are written, whether they're going to be slanted or straight. And then you can add grid lines if you want, more or less grid lines. This looks fine to me, so I'm going to end it here. All right, now I have a good looking graph. You can copy and paste this into your lab report now. So I'm going to try. although sometimes it doesn't work that well. So um, let's see here. So I'm going to try Command C. If I'm doing this wrong, maybe someone else can correct me in the comments. I'm going to go to the place in Seth's lab report where it asks for a graph, and that's number 7. Okay. And I'm going to do Command V. Okay, it's not working right now, so I'm going to do it a different way. I'm going to take a screenshot instead of this graph. So Command Shift 4. Command Shift 4, highlight the graph that I want. And I'm going to insert it into the lab report. I'm sure there's a way to copy and paste a live graph from Sheets into Docs, and I'd love to know it. If somebody figures that out, you can comment under this post. Okay, so insert image. It might come up there. It looks like Seth has hidden some of his menu items. You're going to choose it, and if you take a screenshot, it shows up on your desktop on your computer. So there's my screenshot. Choose it, get it in there. Looks nice. And then I have to add a title. Usually you add figure labels underneath any pictures that you put in your lab report. You have to add a title so that the reader knows, well, what is this thing that you put in here, and you can refer to it later. So I've added figure 1 drop times for rotocopter models. You should have capitals on your any kind of title or label. Okay, and then in your conclusion, you can say things like, according to figure 1, the drop time decreased as number of paper clips was increased. It looks like Seth and Jacob already added a graph here. It's pretty good, although I would work on your title. It needs to be more descriptive. Your legend isn't that clear, so your legend is just some dots up here. I don't know what those colored dots mean. And your y-axis label needs to be more descriptive too. So seconds, well, what did you measure in seconds? The time it took to throw it across the room, or to drop it, or to crumple it into a ball, we're not sure here. So make sure that your graph has a clear title. It's got a clear legend. It can actually show the data you're trying to prove. And then it's got a clear x-axis label. How did you manipulate the variables? 1, 2, 3, 4 paper clips in this case. And then a clear y-axis label with the units. So what did you measure? What's the responding variable? That should be on the y-axis. And what units was it measured in? Okay. So here you're going to make a conclusion. Create a couple sentences that talk about the manipulated variable and how it affected the responding variable. So in this case, you could write something like, as the number of paper clips were increased, the drop time decreased. The hypothesis was shown to be correct according to data in figure 1. Something scientific like that. So take a look at your hypothesis. Did your data prove what you were trying to demonstrate? All right, then take a look at the questions that are down at the bottom of this lab. What are some sources of error for this lab? How could you do this with more precision? Use a laser timer, use a photogate timer, actually measure some of your drop times. Did it fall on the stairs? So was it inconsistently measured? Was there human error in when you stopped the timer? How could it be done better? List some things down there, or list some extensions for the lab. What is a manipulated variable? Part B. And give an example from the lab or in other places. What is a responding variable? Give an example. In this case, it was time. It's how the models respond to your manipulation. So we measured time. And then controlled variables. Controlled variables are things that you keep the same throughout any lab test. So for the rotocopter lab, you kept the drop height the same. You had to keep the drop height the same or it wouldn't be a fair test. You kept, if you changed paper clips, then you kept the size of your rotocopter the same. You maybe kept the person that did the dropping, that was the same person each time. The person that did the timer was the same person each time. Those are called controlled variables so that you're not getting errors introduced through other means. Like if there was a wind in the hallway, if somebody messed with your lab, those are uncontrolled variables that would create a source of error. Okay, so controlled variables in this lab, you're only allowed to test one variable at a time. The other variables have to be controlled. So this is part E. Why can a scientist only test one variable at a time? Think about that. Give a good answer here. Why can I not just make 3 or 4 different rotocopters that vary in every way between each other, like a crumpled ball, a paper airplane, a rotocopter with 4 paper clips, drop them, and then make a conclusion? Why would that be confusing? Take a guess down here. We'll talk about it Friday, and then hopefully we'll submit this lab before the weekend is done. Okay, have a good rest of your day. I hope we get caught up, and we'll see you Friday. Bye-bye.